Okay, so now we've gone over all the different phases of the coil gun with the exception of the launch. The launch is quite simple actually. Instead of having the flash, what we've done instead, in this case, here's an example of the coil gun that one of us made. We didn't use the flash circuit, but we used the voltage that the capacitor could induce and the current, and hooked the switch up to that to where once it was charged it would induce a voltage or a current change in this coil that we wrapped around a tube in which we put a BB, which is a ferrous magnetic material. I've assembled a few diagrams here to help us understand what's going on. The first principle that's important to understand is that whenever we induce an electrical change in current or voltage in a conductive material, for example a wire, as you can see here, it creates a magnetic field perpendicular to the flow of the current. And so in a straight wire we would see a current around that wire. In our case, what we've done is we've taken that principle and we've wrapped the wire into coils. What that does is effectively increases the size of that. What would normally be wrapped around one wire is wrapped around multiple wires. So we begin to see a magnetic field of north to south, perpendicular once again to the flow of the current that you see here in red. So here's the flow of the current, here's a magnetic field that's perpendicular. Now in the case of here's another example of that too, as a matter of fact. For once we have the current flowing and then we have a magnetic field that's perpendicular to it. Where that comes into play is in our coil gun. And what we've done here once again is we've coiled up this wire, and so effectively if we were to change the current or voltage in this wire, we would create an electromagnetic current, or electromagnetic field, excuse me, that could be used to induce a current, or that field could be used to induce a current in a small ferrous material that's inside of this and used to propel it. That principle is easily seen here in this diagram, where we have a projectile. In our case it was a BB, in this case it's a cylindrical item, but as the current is induced through this coil, a magnetic field is created perpendicular to that wire, and thus it's forcing or pulling, whichever way you're looking at it, that ferrous material through the field. In our case, it happens quickly enough to where the BB, in our case, we position it just right inside the field, and as it pulls it through, it discharges before it can be stopped in the middle. If it wasn't discharged and experienced a constant change, it would pull to the center and it would stop. In our case, we discharge before it reaches the center, and thus the velocity that we create, it accelerates, we cause some velocity, we create a moving BB. It's fully discharged by the time it gets to the center and is shot out. And so that is how the launch works.